In this video, I'll be repairing the cruise control system on a 1988 Porsche 944, as well as providing an overview of the primary system components and common troubleshooting steps. Some symptoms of a problematic cruise control system would include failure to engage the automatic speed control, failure to maintain speed after engagement, gaining a set amount of speed after engagement, and intermittent functionality. Fortunately, it's not terribly difficult to replace the various parts in the system, so let's take a look at the primary components. The cruise control function is operated by the switch stalk on the right side of the steering column, and here we'll see three different settings listed as Set Accelerate, Reset, and Cancel. Pushing the switch forward engages the cruise control and sets the memory at the current speed, and when it's held down, it will slowly accelerate the car. A pull back on the stalk will cancel or disengage the cruise control setting, and pushing the switch down will resume the last speed setting for memory. This functionality is listed out in greater detail in the 944 Owner's Manual, with an item of note being that the cruise control will only engage at speeds of 25 miles per hour or greater. Below the dash, in the driver's footwell area, we'll find the control unit, or the system computer, as well as a clutch pedal switch. The computer manages all the cruise control system functionality, and the clutch switch breaks the circuit and disengages the cruise control when the clutch pedal is depressed. On the earlier cars, the computer is located under the center console behind a cover panel just above the accelerator pedal. Moving into the engine compartment, we'll find the cruise control servo, or actuator, on the right side of the car in front of the battery. The actuator is connected to a cable and some linkage under the dash that controls the movement of the accelerator and therefore the throttle based upon electrical signals from the computer. Inside the actuator is an electromagnet over on this side that engages the gearing, and the servo motor sits at the back here, and it drives the gear to turn the actuating arm forward and back to regulate the vehicle's speed. So now that we've had a look at the main system components, let's check out some troubleshooting steps. When troubleshooting cruise control issues, you'll first want to inspect the throttle cables for any damage and correct adjustments, ensuring the cables are properly connected and eliminating any loose play in the cables using their jam nut setup. You'll also want to access the fuse box to check the fuse for this circuit, and you'll notice here that it shares wiring with the brake lights on this car. The fuse is number 19 at the fuse panel on the later cars, and number 8 at the central electrical panel on the early cars. If the fuse looks okay, you'll next want to confirm the functionality of the brake light bulbs. The control unit for the cruise control uses the brake light bulbs as a ground in this system, and if both brake lights happen to be defective at the same time, the computer won't function. So check and replace the brake light bulbs as necessary. Moving down the list, the function of the clutch pedal switch should be tested as well, where the switch should be closed when the clutch isn't depressed. The factory workshop manual indicates to adjust the clutch pedal switch so that the distance between the end of the threads and the clutch pedal in a neutral position is 4 millimeters. As a reference point, you can see when testing resistance on the switch that it engages when the switch button is depressed about halfway in, which is slightly more than 4 millimeters from the threads. To remove or adjust the clutch pedal switch, one of the 17mm jam nuts will need to be released, either using an open-ended wrench on the inside nut or a 17mm deep socket on the outside nut. If you find that the switch offers no resistance on an ohm meter when the button is depressed, the switch is defective and it can be replaced for around $50. The next troubleshooting steps involve inspecting the multi-pin plugs to the control unit. The upper plug is the instrument cable where voltage can be tested using a voltmeter, and the lower plug is for the actuator or the drive unit where resistance is tested using an ohm meter. To test the wiring for the cruise control system with the ignition turned off, disconnect both plugs to the control unit. Next, apply the voltmeter probes to terminals 4 and 8 on the upper plug. Switch the ignition on, and the reading here should be battery voltage, or approximately 12 volts. Now connect the probes to terminals 2 and 8, and the reading should be 0 volts, and when the brake pedal is depressed, it should read battery voltage. Applying the probes to terminals 3 and 8 should read battery voltage, and when the cruise control is switched to the cancel position, it should drop to 0 volts. Connecting the probes to terminals 5 and 8 should provide 0 volts, and when the cruise control is switched to the reset position, it should read battery voltage. Testing terminals 6 and 8 should show 0 volts, and when the cruise control is switched to the set accelerate position, it should read battery voltage. And finally, connecting the probes to terminals 4 and 7 should read battery voltage until the clutch pedal is depressed, where it should drop to 0 volts. If everything checks out okay here, you've confirmed that the cruise control switch and the wiring are working correctly. The next series of tests involve checking the cruise control servo and its wiring using the lower multi-pin plug. Here, an ohm meter can be connected to terminals 1 and 2, and the reading should be between 30 and 40 ohms. Next, applying the meter to terminals 4 and 7 should result in 2,000 to 4,000 ohms, and applying the meter to terminals 4 and 8 should also yield 2,000 to 4,000 ohms. And finally, connecting the probes to terminals 5 and 6 should read between 20 and 30 ohms. If there are any variances from the factory specifications here, the servo unit should be inspected or replaced. To replace the actuator, the wiring will need to be disconnected in the engine bay, and the various 10mm screws around the mounting bracket will need to be removed. OEM Porsche replacement units will run north of $800 on the servos, and used ones can be found between $50 and $100. The units can also be disassembled, cleaned, and lubricated as needed. If no defects are found with these tests, the cruise control computer should be replaced. As a side note, there's a similar testing procedure outlined for the early cars in the Factory Workshop Manual, Volume 1 Engine, Section 27-11, where the primary difference is that the wiring harness connector is one single unit, so feel free to check that out if you're working on an early car. After testing the various electrical components in the system, I'm pretty confident that the cruise control computer on this car has malfunctioned, which is quite common across the 944 models. Before swapping it out, I'd like to open it up, inspect the circuit board, and see if there are any obvious failure points. The control unit is secured to the car by two 10mm mounting nuts, one on each side of the assembly. So all we need to do is loosen and remove the two nuts, and then the unit can be pulled down slightly and the wiring harness is disconnected. Here's a closer look at the control unit, and we can see that the aluminum housing is crimped onto the plastic connector plate in a few locations. What we'll need to do is gently lift and bend those out slightly using a flathead screwdriver or a similar tool. Once you work your way around the edges to create some space, the circuit board can be safely pulled away from the housing. After inspecting the board, I'm not seeing any clear damage to the electrical components. Nothing is leaking, swollen, or fried from what I can tell, and the solder joints on the underside appear to be intact with no obvious damage or cracked welds. This is a 35-year-old circuit board, however, and it wouldn't be uncommon to find a number of cold solder joints or miniature fractures across the board. If something stood out as a clear issue, that joint could be resoldered or reflowed to repair the circuit, but in this case I'd be taking a shot in the dark in deciding which of the joints to hit with a soldering iron, so what I'm going to do is attempt to reflow the entire board using a heat gun. This is just a conventional heat gun with high and low settings, not specifically made for solder work, but it should allow me to cover a broad area of the board fairly quickly. As a disclaimer, this is not a factory recommended procedure, and it's quite possible to overheat and damage the board. So if you're not already prepared to replace the control unit, I wouldn't recommend this step. With that said, let's hit it with some heat and see if we can get the solder flowing again. I started out with the low heat setting, hovering over a section of the board, and I was trying to determine about how long I'd need to hold it there before the solder started to soften up. After about 20 seconds, I could feel that things were heating up, but it wasn't quite hot enough to get things flowing again. So I bumped it up to the high heat setting, and about 10 seconds later, I could see the protective coating start to bubble up a little bit, and immediately thereafter, the solder on a number of the joints softened up and drew in closer on their connections. So that was a pretty good indicator to move on to a new section of the board. I tried to move quickly, applying just enough heat for the desired effect, and then moving on. Again, you'll want to use some caution here and not linger too long in one particular area to avoid the risks of damaging the board or possibly starting a fire. So take some safety precautions if you attempt this. Once the entire surface of the circuit board was covered, I let it cool down for about 10 minutes and inspected its overall condition. There was some slight discoloration to the protective coating on the underside, but other than that, all the components appeared intact and undamaged, so it's time to reassemble the computer and test it out. When reinserting the board into the housing, you'll notice there are two sets of guide rails inside that the board rests on, so gently push it into those notches, and then the metal tabs can be crimped back down onto the plastic connector plate, and the unit reinstalled in the car. Once the computer was reinstalled, I took the car out to test the cruise control, and it engaged right away on the first attempt, with no irregularities in the system functionality. The drive setting is now engaging and accelerating as expected. The cancel switch, the clutch pedal switch, and the brake pedal switch are all disengaging the system as they should, and the resume function is working as well. The speed setting is nice and steady with no surging in the throttle, and it remained that way for about a 20-minute drive, so I'm going to test the system out a bit more over the coming weeks, and if it happens to cut out again, I'll probably pick up a second-hand unit to replace it with, since the OEM Porsche units run close to $800 compared to about $60 for the used ones. But for now, things are looking good, so it's time to hit the roads.